Okay, so I've started recording now. So thank you, Ogechi, for that. Um, so that's the definition of the Z transform. So remember, so what we just did here is to replace y of k of t with y0, then when k is 1 is yt, when k is 2 is 2t, when k is 3 is 3t, because this is definition of the ramp. Then if you look at this, you have 0 when k is less than 0. But remember that your Z transform starts from 0. So you don't even need this one. And even it's 0, so it's going to become 0. So you don't even need it because the Z transform starts from 0. So when k is greater or equal to 0, you have k of t. So in place of this y of 0, y of t, y of 2t, y of 3t, replace it with k of t. So y of 0, z minus 0 is 0. So you have 0. So y of t, remember that y of k of t is k of t. So instead of y of t, we just replace it with k of t. Instead of y of 2t, we replace it with k of t. So we do that. So for this, remember that this is when k is equal to 0, this is when k is equal to 1, this is when k is equal to 2, 3, 4. So in place of k, we are replacing it with 1. K is 1 here, so you just have t here. K is 2 here, so we replace k with 2. K is 3 here, so we replace it with 3. And remember, we're also replacing this. So, and remember, we are also replacing these two with k, because as you keep incrementing, k is increasing. So replace it with k, then for k, so yeah, k is 4 and k is 4. So we just replace it with 4 here. So if you look at this geometric series, if you look at this summation is not a geometric series. And let me go back to the first one. The first one is a geometric series, because you know that when this is the first term, this is the first term, this is the second time, so this is the third term, and so forth and so forth. So if you multiply the first time by 1 over z, you will get this. If you multiply this by 1 over z, you get this. If you multiply this by 1 over z, you get this. So this is geometric series because it has a common ratio. But in this case, let's go back to this example. In this case, this is not a geometric series because, okay, the first term is 0. This is the second term. Okay, you can say that if I multiply this term by 2 over z, I will get this one. But then, if you multiply this by 2 over z, you're going to get 4tz minus 3. You're not going to get 3tz minus 3. So this is not a geometric series at all, because it doesn't have a fixed common ratio. So you cannot use the formula we used in the previous example. You cannot use it to get the Z transform. So you have to use an alternative method to actually get the Z transform. So the alternative method we are using now is, this is the definition of the Z transform. So you differentiate both sides. So let me go over it again. We cannot use the method we use in solving the unit step to solve for this, because this is not a geometric series. So we have to use an alternative method. So the alternative method we are going to use is to differentiate both sides. So you differentiate this and you differentiate this. So you get this. Then here, you are just shifting dz. You're just shifting it over here. So instead of it here, you just shifted it to this point. So this is something as this. Then now we differentiated z minus k. So when you are differentiating, minus k will come down. Then you put -1 here. So you simply have this. Then you multiply both sides by minus tz. And sorry, I just want to connect my laptop to a charging source because it just brought the light. So if you have any questions, just post it on the chat so that so if you have questions, observations, just okay. Somebody said, please, ma, why are we using x of k? Okay. So the reason why we are using x of k is that so the reason why we are using x of k, like I told you, we cannot use the previous. So thank you very much. Thank you very much for the questions. X of k is the definition of a Z transform. So let me go back to the definition of a Z transform. So this is the definition of a Z transform. X of Z is equal to the summation from k is equal to 0 to infinity, S of k, x, Z minus k. So for those of you asking that, why are we suddenly using S of k? We are going to, by the time we complete it, you would know the reason why we are using it. And another person asked that, why are we multiplying by minus tz? So when I explain this line, then you will know the reason why we had to multiply by tz. So thank you for your questions. So, but for the first question, which says, why are we suddenly using S of k? This X of Z is the definition of a Z transform. So this is the definition of a Z transform, which is what we started with. So that's the definition of a Z transform. So I didn't get it from anywhere else. So this is the standard definition. So what I just did is just to copy the definition there. Then the reason why we are differentiating, let me answer the question for the reason why we are differentiating. The reason why we are differentiating is because, you know, for the first, look at the definition of a unit ramp. A unit ramp is kt multiplied by a unit step. U of k is the unit step we started with. And this is the definition of a unit ramp. So from, you would know that a unit step, if you differentiate a unit step, you will get a unit ramp. So the reason why we have to differentiate is that we want to differentiate the unit step so that we can get the unit ramp. That's why we are differentiating, because normally a step signal, like a step signal, when you differentiate a step signal, you will get a ramp signal. So we are just starting with the unit step, and we are saying that let x of k be equal to the unit step. Then we are differentiating the unit step because we know that the differentiation of the unit step is the unit, is going to give us the unit ramp. So that's the reason why we had to differentiate. So when we differentiate, we got this. So like I said, you would just shift this here. Then you would shift the z. Then it will come here. So now you are differentiating z minus k. So when you differentiate z minus k will come down. Then you have minus k minus 1. So that's why you have this. So the next thing, we are multiplying by minus tz. So somebody has the question, why are we multiplying by minus tz? So let's just do it first, then I will tell you the reason. But the reason is that, okay, let me just tell you the reason. The reason why is because when you multiply minus tz with the difference, with differentiating the z transform of the unit step, you are going to get the unit ramp. Let me say it again. The reason why we are multiplying by minus tz is that after you do all of this, when you multiply minus tz by the differentiation of the unit step, you are going to get the unit ramp. That's why we are doing it. That's just the answer to your question for the person that asked that question. So let's just multiply it. So I moved that edge because of that question. So when we multiply by minus tz, we multiply both sides by minus tz. So we multiply both sides by minus tz. Then we get minus tz here, then minus tz here. So this is simply what we add here, but we simply multiplied by minus tz. So when you multiply minus times minus is plus. Minus times minus is plus, so there's no minus here again. K times t is kt. Then z minus k times z is going to give you z minus k. So that's why you have this z minus k here. So when you do this, you arrive at this. Then if you would observe, this particular expression we got is the same thing as this, except the kt. So if you look at it very well, this here is the same thing as this, except the kt here. So that means that when you multiply the differentiation of of x of z, then you multiply it by minus tz, you are going to get the z transform of the unit ramp. So that's the reason why. So I actually explained this because of the question. Okay, somebody asked that, but why is x of k equal to u of k? So the reason why we just made x of k to be equal to u of k is because when you differentiate u of k, which is the unit step, you are going to get the unit ramp. So we are just saying that let x of k be equal to u of k. So somebody said tz, not lz. Yes. So we are multiplying by minus tz. If you can see my cursor, we are multiplying by minus tz, not minus lz. So thank you for the correction, the person that pointed it out. So that goes back to my to this point. I answered that question before we got there. So we just said that let the x of k be equal to u of k, which is the unit step. Then from what we got here, when you multiply the derivative of a unit step signal with minus tz, you are going to get the unit ramp. You're going to get the unit ramp. So that's the conclusion. So the conclusion says that the z transform of the unit ramp is equal to minus tz the differentiation of the unit step. So this might be a little bit confusing at first, but when you go over it, just try to go over it again after the lecture. So this is what we proved. So I'm just writing it again. So what this simply says is that the Z transform, so this is the unit ramp. So the Z transform of the unit ramp is simply minus TZ, then multiplied by differentiation of the unit step. That's what it simply says. So let me say it again. The Z transform of the unit ramp is equal to minus TZ multiplied by differentiating the unit step. So that is just what we've proved. Okay, somebody just wrote on the somebody just wrote on the chat that when the time expires, that instead of creating another new link, I can just refresh the same link. So thank you very much. Thank you very much for that, Gideon Peters. So I'll just do that. So when the time expires, I'll just refresh it like you said. So you said I don't have to create another new link. I should just refresh it. Okay, so thank you. So thank you for that. So I will do that. Thank you. So let's go on. So let me just repeat what I said. So from this derivation, the reason why we are doing all these things we did here from year to year is to prove to you that when the Z transform of the unit ramp is equal to minus TZ multiplied by differentiating the unit step. So that's what we wanted to prove, and we've proved it. If you're having difficulty in understanding, then just go over the notes, then you would understand, or just mail me privately for more explanation on that. So since we've been able to get to this point, so what we simply do, you know, in the first example, we got the Z transform of the unit step. We got it as Z divided by Z minus 1. So let me just go back to that example. So for the first example was the unit step. So we got it as Z minus 1. So since we've been able to get to this point, so we already know the Z transform of U of K. And the Z transform of U of K is Z minus 1. Is very clear. Remember that we've gotten this in the first example. We got the Z transform of U of K as Z divided by Z minus 1. So simply, I just replace this with this since we've already gotten it. So when you differentiate this expression, so I skipped a lot of steps for the differentiation. So I would encourage you guys to try to, when the lecture is over, just go over the differentiation of Z minus Z divided by Z minus 1. Just go over the differentiation. You're going to get this. So I decided not to put it down there because it's just differentiation. So it's differentiation. You write this one, differentiate this one, then you write this one, differentiate that one. So is normal differentiation. So we got this. If you're having any problems with that, just try to see for yourself. I skipped this step. So when you do the arithmetic, you are going to get this. So I skipped a lot of steps in this particular line. So I encourage you to prove that when you differentiate this, you're going to get this, and when you do the arithmetic of this, you will get this. So I'm encouraging you to do that. So in fact, in the second quiz, I'm going to be telling you to prove this. So you prove this from here to here. So it's important for you to really understand. I want to be sure that you really understand what's going on there. So it's just simple maths. It's just simple maths. So somebody said, Sam said that we want to get the recording of the class for proper understanding. Okay, yes, I'm recording. So I'm recording it. So after the class, I'm going to post the recording on the Moodle platform so that everyone of you can see it. So thank you for that comment. So like I said, I'm going to be giving you a quiz uh, on you proving okay, somebody said it's not easy to type calculations for quiz or Moodle. All right, so but that will be my next quiz actually, so you guys have to do that. So immediately after this class, I'm posting the quiz, which is to prove that from this you get this. So everybody be prepared for that. It's just simple maths. So we have been able to get that the Z transform of a unit ramp is given by this. So if you check the lecture notes, I actually wrote this down. So this is the solution for that. So everybody should get prepared to be able to prove this. So let's go to, if there are any questions for example 3, let me know. So I'm going to, sorry, for example 2, let me know. So I'm going to the example 3. So example 3 says that the Z transform is given by this. Yeah, somebody asked, is there a way we can scan or snap and upload on the Moodle instead? Yes, yes, exactly. So I'm teaching another course. So they had to do a calculation. So I told them to write the calculation on a piece of paper, to snap it with their phone and to send it as an attachment on the Moodle platform. So that's how I graded them. So you're going to do the same thing. You're going to do the calculations on paper. You're going to snap it with your phone or you scan it if you have a scanner. Then you upload the picture to me on Moodle. So that's how you're going to do it. So thank you for that. That's how you're going to do it. Someone said, what if your camera phone is not? You have to get I have to see a good picture. Otherwise it's 0. If I can't see what you've done, is 0. So let's just move on. So the example 3 is the Z transform is given by this, and you are asked to sketch the time response of the signal. So that's the question. So remember the definition of Z transform. The definition of Z transform is you are summing from 0 to infinity. You are summing the signal. So the signal is in time domain, then you multiply by Z minus K. But in this case, I'm representing the signal. Someone said, yes, ma'am, please, enough time. Okay, all right, no problem. I'll give you enough time to do that. So let's move on to the example 3. So we are asked to sketch this signal, sketch time response of this signal. So this is the definition of the Z transform. So I'm not doing anything here. So because of Y of Z is here, I said Y of Z. Then because of, this is the Z transform and this is the time domain. So that's why, in time domain, it is Y of K. So it's supposed to be Y of K, not Y of K2. So it's supposed to be Y of K. Yeah. So this is just the definition of the Z transform. And the reason why I did that is because I should have put X of Z, but the question was Y of Z. So I have to put Y of Z here. And since the Z transform is Y of Z, the time domain form is going to be Y of K. So that's why it's like that. So this is the definition of the Z transform. Then if you look at the question properly, you observe that in this definition of the Z transform, you know, K starts from 0 to 1, 2, 3, 4, 5, then to infinity. Yeah. But yeah, it's starting from, you know, this is Z minus 3, and you have Z minus K here. So it's starting from Z minus 3. Z minus 3. So the conclusion of that is that the previous terms are 0. So what I'm just doing here is to write this, but to write it in terms of the definition of the Z transform. This is the question. We're not giving Z minus 2. We're not giving Z minus 1. We're giving, we started from Z minus 3. So that means that the x of 1 is 0. The x of 1 is 0. The x of 0 is 0. And the x of 2 is 0. So this question is simply, I'm just writing this. So I'm just writing this as this. So that's what I'm just doing. But then, since we're not giving Z minus 1, Z minus 2, I'm putting 0 there. So this is just the definition of the Z transform. So this is just the definition of the Z transform. From the charts, some people are writing their matric number. I can see that some people, you think I'm here to take attendance. I'm not here to take attendance. I'm just here for you to understand. So no need to write your matric number. No need to write your name. It's just for you to understand what I posted on the platform. So I'm not taking attendance, just for you to understand. Okay, so if you all understand what I did, so it's just this, then yeah, I'm just expanding the question out in form of the definition of the Z transform. Then when the question says you should sketch the time response. So from what we've gotten here, this is K is 0. So for K of 0, you have 0. So there's 0 here. So this is when K is equal to 1. For K is equal to 1 is 0. So you still have 0. This is when K is equal to 2. For K is equal to 2, it's still 0. So you have 0 here. Then for K is equal to 3, you have 1. So that's why you have 1. If you trace it down, then you have 1 here. For K is equal to 4, the amplitude is 5. So this is K is equal to 4. If you trace it here, you have 5. Then for K is equal to 5, the amplitude is 12. Then for K is equal to 6, the amplitude is 15. So I need feedback from you regarding this plot. Do you understand how from this we're able to get this? I need some feedback from you. I need feedback. Do you guys understand how okay, a lot of people are saying yes. Okay, thank you very much. Thank you very much. So from here, you're just simply plotting the amplitude. So thank you for the people that responded. Okay, somebody said, why is it KT? Why is it KT? So I said it's a mistake. It was supposed to be Y of K. It was supposed to be Y of K, not Y of KT. And somebody said, where are the amplitudes coming from? The amplitudes are coming from the question. Is the question. I didn't manufacture the amplitude from anywhere. This is the question. This is the same thing. What is here is something as what is here. It's just that for the question, you notice that they are not as, there's no Z minus 0, Z minus 1, Z minus 2. So that means that the amplitude is 0. So that's why I just put 0 there. So the reason why I did that is for you to understand why the time response of the question is this. So Zoom is telling me that I have 5 more minutes. I have 5 more minutes before my time will expire. So let me just, so I'll move on to the fourth example. Like the person, like Gideon told me, Please, now you're going to edit this note and re-upload because all of the mistakes we've noticed. Okay, all right. All right, I would. It's just one mistake so far. So if you are following, there will not be need to re-upload. So it's just one mistake so far. But I would re-upload. So if you notice any mistake, just let me know so that I'll correct it and re-upload. So thank you for that. So I have 5 more minutes before Zoom is going to stop this. But this question is the inverse Z transform. So if you read the original note, I talked about the inverse Z transform. So for the Z transform, you have your signal. Somebody asked that, can I finish this example in less than 5 minutes? No, a big no, I can't finish it. And this example is very, very important. It's very, very important. So like the other student told me that I should refresh once it's over. Once the time is over, I should refresh it. Then I'll be able to get back the time again. So I think what I'm going to do, now is somebody asks if in the equation is y of k, why is it ykt on the graph? Okay, thank you for the good question. So actually it's actually y of kt on the graph because for discrete time signals, when I started this class, I said that on the x-axis, that's the independent variable is an integer. So it has to be an integer. The independent variable has to be an integer. So thank you for this question, Chidima. Thank you for this question. Actually, you can represent it with y of k or y of kt. Anyone goes. Thank you for this observation. So it can either be y of k or y of kt. Both of them are correct. Both of them are correct. Either y of k or y of kt. Because when you're actually drawing it on the graph, you need to draw it as y of kt because k is from 0 to 1. So thank you for the observation. So to respond to Chidima's observation, you can either represent it by y of k or y of kt. Both of them are correct. The reason why I was saying that you should just use y of k instead of y of kt is that when I started the definition, when I started this with x of k. I didn't put x of kt. That was why I said that you should just forget about the t. But it's the same thing. Either you put x of k or x of kt. It's the same thing. So thank you for the observation, for the correct observation. So both are correct. Y of k or y of kt. Both are correct. Just use anyone that is suitable for you. So I have less than 2 minutes. So and the last question is inverse. The last question is inverse Z transform. So the last question is very important. It's very, very important. So what I'm going to do now is I'm going to end the meeting. Then I would rejoin using the link. I will end the meeting now so that we can just do this last one and exit. So